Welcome back to your favorite YouTube channel, Algebra 2. Today, we're going to be looking at vertical stretches and vertical compression. So let's jump right into it. So for this example, we're going to be looking at the equation f of x equals the absolute value of x. And what we're going to do is this little piece tells us that we're just going to specifically look at the values from -4 to 4, just so that we can kind of zoom in on our graph. So we've also got this rule, g of x equals 2 times f of x, and we're going to use that rule to help us plot points to figure out what our new g would be. So the first thing we should do is figure out what our f is. So if I plug in -4 in right here for x, the absolute value of -4 is 4. Okay, if I plug in -2 in here for x, the absolute value of -2 is just +2, because remember, absolute value is distance away from 0. -4 is 4 away from 0, -2 is 2 away from 0, 0 is 0 away from 0, 2 is 2 units away from 0, and 4 is 4 units away from 0. Okay, so let's go ahead and just quickly plot that. So that's -4, comma 4, -2, comma 2, 0, 0, 2, 2, and 2, 4. And then I've got that familiar V shape that we know, or that we've seen absolute value graphs have. Okay, so then the next thing we want to do is figure out what our new points would be for g of x. Oh, before we do that, let me just go ahead and label this is our graph of f. So we want to figure out what our new points for g of x would be following this rule. So we're doing 2 times f of x. So let's go ahead and get started. So we're going to take g of -4, and I have to write kind of small here, so I apologize for that. So g of -4 equals 2 times, and we're going to plug that -4 in for x again. So we actually know what f of -4 is. When I plug in -4 in for f, the output is 4. So really, this is just saying 2 times 4, and that gives us 8. So the new coordinate for g is going to be -4, comma 8. And I can go ahead and plot that. So -4, comma 8 is all the way up here. Okay, let's do the next one. So this time I'm going to plug in -2 in for x, wherever I see an x. So it's g of -2 equals 2 times f of -2. Now, I already know that this, when I plug in -2 in for x, I'm going to get out a +2. So I'm just going to replace that. So I really have 2 times 2, and that's 4. So the new coordinate for g is I plugged in 2, and I got out 4. Plug in -2, and you got out 4. Here we go. Okay, let's try 0. So g of 0 equals 2 times f of 0 equals, let's figure out what that is. So I know f of 0. So when I plug in 0, I'm going to get out 0. So really, this is just saying 2 times 0. And then 2 times, or anything times 0 is always going to be 0. So 0, 0 is going to stay the same. All right. And then we've got g of 2 equals 2 times f of 2. And that equals 2 times 2, because when I plug in 2 in for f, the output is 2. So that's where that 2 is coming from. So 2 times 2 is equal to 4. So this point is going to be 2, comma 4. So 2, comma 4 is right here. And then let's do the last one. So g of 4 equals 2 times f of 4, and that equals 2 times 4, and that equals 2 times 4 is 8. So this coordinate is going to be 4, comma 8. Okay, and I've got another V shape right here. And this is my graph of G. Okay, so how are the domains and ranges related? So we're going to keep coming back to this idea of domain and range. So let's see, the domain for f, and I'm going to write this in blue. So the domain for f is from -infinity to +infinity. because it's going all the way to the right. Oh, actually, no, I lied. So the domain we were told up here is from -4 to 4. So specifically, we were looking at the domain of -4 to 4. So really, these points should stop here. There's no arrow because we were told that. Okay, and then the range would be from 0 to 4. Okay, now let's look at the domain and range for G. So the domain is actually going to be the same. So our inputs didn't change. So our domain is from -4 to 4 with brackets to include those values. And the range, our lowest value is 0, and that's included. And our highest value here is actually 8. So if you notice, the range actually doubled. Okay. And I mean, if we double the 0, 2 times 0 is still 0. So our range doubled. Okay. So the relationship between the coefficient of the function f of x is equal to a times x. Maybe I should use a different highlighter here. So what this is actually going to give us is a vertical stretch. And we can see that when we plug in a number like 2 or 3 or 4, we're going to get a skinnier graph, and they get vertically stretched. So that point goes up, this point got vertically stretched, this point got vertically stretched, and this point got vertically stretched. Okay. Whereas if we have something like m of x equals, let's say, 1/4 f of 4, this would be a vertical compression. And that would make our graph fatter. So when we plug in a whole number like 2 or 3 or a whole number or a number that's bigger than 1, so we could have plugged in 1.5 and we would have gotten a skinny graph like the one in pink. And if we plug in a fraction, then we get a vertical compression. Thanks for watching.